Alright, here's example number 2 of our rational equations. That looks way too much like a 1. Number 2, x minus 4 on top, x squared minus x minus 2 on the bottom. First thing we'd try to do, if we can factor top or bottom, we should do that. Can't do anything on top. On the bottom, it's going to become x minus 2 and x minus 1, or x plus 1, sorry. So that means we should be able to get our domain for the denominator. Denominator equals 0 at x equals 2 and at x equals negative 1. So you need everything except for positive 2 and negative 1. So negative infinity to, well, might seem like common sense, but make sure you go in proper order. Negative 1 comes before positive 2. So then I need everything between those two numbers, and then I need everything after that. Okay, so what is key here, you have two different domain errors. That means you need to have 2 breakpoints, which means you need to have 3 total domain regions here to work with. Okay, so there's your domain. Domain also, we said, deals with 2 other things, the vertical asymptote and the hole. So let's take a look at those. Both of those, 2 and negative 1, are either going to be a vertical asymptote or a hole, depending on whether or not they cancel with the numerator. Well, nothing cancels with the numerator, so that means that there is no hole, and that our vertical asymptotes are both of those values, x equals 2 and negative 1. So now we can look at the rest of the problem, the x-intercept and y-intercept. Remember, x-intercept means that y equals 0, and y-intercept means the opposite, that x is equal to 0. So for the first one, for y equaling 0, that means the entire function equals 0. That means the numerator equals 0. So x equals 4 will be your x-intercept, so 4, 0. The y-intercept, when x equals 0, if you plug 0 in everywhere, and it doesn't matter whether you do that in the factored form or in the original form. Personally, I think it's easier there in the original form. You get negative 4 over negative 2, so you get a y value of positive 2. All that's left now is the horizontal or slant asymptote and where it may cross that value. So when you use long division, the top goes inside, the bottom goes outside, and again, use before you factor for this, you have to. And your question would be, x squared times what would give you x? Well, that's kind of backwards. X squared times nothing gets you x. I mean, you could technically say 1 over x, but that's not a polynomial. We're doing all with polynomials in these rationals. So what really is going on here, you can't do the long division because your denominator is already bigger than the numerator. So think of it this way. If you had a fraction 5 over 3 and you did long division, you could get your 1 and 2/3 when you do that division. If you have the fraction of 3 over 5, however, so it's like 1 plus 2 over 3. When you have 3 over 5, you can't do that division. It's like you have nothing in front of that 3 over 5. So it's technically like you've already done long division. Like you have a big 0 out in front. That means your horizontal asymptote is y equals 0. It's a number, so it's horizontal and not slant. And then here's where the tricky part of this can come in. You cross your horizontal asymptote when the remainder equals 0. Well, your remainder equals 0. This is the remainder, technically. So you have to cross at x equals 4. Is where you cross your horizontal asymptote. So now if I try to graph all this, we have our vertical and horizontal asymptotes. We'll draw those first. Our horizontal asymptote is at 0, y equals 0. And your vertical asymptote is at both negative 1 and at positive 2. So we draw our dotted lines to represent that. Now we have to draw some points. We have a x-intercept at 4, 0. We have a y-intercept at 0, 2. And we have, what else? We have that we cross the horizontal asymptote at x equals 4. Well, hey, guess what? We already have that at x equals 4 right here. So what we have going on is we have to try to connect these dots, but we cannot cross over a vertical asymptote. So, well, the only way I can draw this, connecting the dots and going with the asymptotes is kind of to make that U and come right back down. These guys, well, we have nothing on the left and right, so it can either be up or down. This one on the right-hand side, it has to cross at that point. That's why we have it. So it's either going to look something like that, or it's going to start below and cross and go upwards. The question is, which one of those is correct? Well, the easy way to figure that out is pick a number, for example, for this left-hand side over here, pick a number that is less than -1. The only way we can do this, because we're right on the axis, normally we would have said, like we did in the previous example, which of course I erased. In the previous example, the asymptote was up high, so either you were crossing the x-axis again or you weren't. That made your decision. So when it's a little bit more difficult like this, we have to just plug in a number. So say we plug in, for example, -3. If you plug in -3, you get a -7 on top, you get a -5, and a -2 on the bottom. So negative divided by negative and negative means that you're going to get a negative value. So that would mean that this part on the left has to be the top part is wrong, the bottom part is what is correct. When you plugged in -3, that's how you confirm that. I'm going to do the same exact thing here for the right-hand side. I'm going to plug in +3 because that's before I cross the asymptote. So if I plug in +3, I still have a negative on top. This is now a positive on the bottom, and it's still a positive on the bottom. So that means that at 3, I should have a negative value, and then afterwards it'll change to a positive value. So something that looks like that. And if you want to check at 5, if you plugged in 5, you would get positive everywhere, which is why that would be a positive value. So you started negative and went to a positive. This is about the most difficult problem that you're going to have because of the fact that the horizontal asymptote is right on the x-axis.